afternoon, everybody. Okay, so I'm David, and I have a wireless mic. I'm talking, right? Can people hear me?
Yes, loud and clear.
Right, loud and clear. Okay, so today I'm going to talk about two things. One is this Bitcoin staking that we're building. We're working hard towards our mainnet launch. And second thing is how this concept can be applied to build forkless roll-ups. Since this is roll-up day, I thought I would talk about that. Okay, so since this is ECC, let me start with the very important event in Ethereum, which is the merge. So proof of work to proof of stake. So ETH mining becomes ETH staking. So this is a change of security model, right? The change of security model from proof of work to proof of stake. But equally important is that it spawned a whole new industry and a staking market, okay? So when you do mining, there's no mining market, but when you do staking, there's a staking market involving hundreds of billions of dollars worth of asset staked on these proof of stake chains, Ethereum being the biggest one, okay? Now, so what is happening here in Ethereum for this staking market is that a security primitive, which is staking, becomes also a DeFi primitive, okay? And on top of this ETH staking DeFi primitive, one immediately, very soon after the merge, in fact, before that event, is people start building protocols on top of that, starting with LST, liquid staking, Lido and Rocket Pool, Coinbase, etc. They're building liquid staking protocol. And more recently, we have restaking pioneered by EigenLayer, restaking built on top of, again, ETH staking as the basic primitive. And now, after EigenLayer restaking, we have LRT, liquid restaking. So many protocols are composing with ETH staking primitive to build more and more DeFi opportunities, new generation opportunities. Okay, so now this is Ethereum, all right? So our project works on Bitcoin, okay? And Bitcoin, of course, is the largest chain. So let's compare the situation after the merge. Okay, guys, something bad has happened to Bitcoin.
No merge.
Sorry, no merge. No merge. They didn't know that merge is no longer just a change of security model. It's actually a change of business model for Ethereum, right? So here we have on the right-hand side Ethereum with this thriving ecosystem of DeFi. And here Bitcoin, poor Bitcoin, still left with Bitcoin mining, very lonely by itself. Nobody builds anything on top of that. Still working hard, but they're working hard. They're mining every day, securing the blockchain, but nothing's happening on top of that, okay? All right, so our project basically is the following. Say, hey, look, Ethereum is doing very well. Bitcoin has no such primitive. Why don't we try to build a native Bitcoin staking primitive on Bitcoin? Okay, all right. When I first said this, people may say, oh, this guy David Shea won't last very long. He'll be massacred by all these Bitcoin maxis because he's advocating a change of Bitcoin from proof of work to proof of stake. In other words, a merge for Bitcoin. It's not going to happen, man. It's not going to happen. So does this question even make sense? Does this question even make sense? Okay, it actually makes sense because the way we answer this question is, yes, we can, but the primitive is not for securing Bitcoin itself, but for securing any proof of stake system, okay? So any system that needs a security in proof of stake requires a capital, right? Requires a source of capital. Now, many chains, proof of stake chains that are launched, are secured by their own native asset. But here we're saying that, hey, you know what? We have a huge, huge asset out there, and not utilizing that asset for security reason is just completely waste. Completely waste. Because we know that security increases with the size of the collateral, the size of the capital. Okay? So here we're answering the question of building a native Bitcoin staking primitive by using it to secure other systems, proof of stake systems. Okay? So this is interesting, right? Because, proof of stake was built to replace proof of work. But actually, we're now advocating essentially the proof of stake becomes use cases of Bitcoin. Okay? Since Bitcoin is not going anywhere, it just keeps on going bigger and bigger. With each cycle, it went bigger and bigger, the asset size. And so we're advocating here Bitcoin, giving a native Bitcoin staking primitive to security chains. Now, so from the Bitcoin holder point of view, okay, a native Bitcoin staking primitive means that you can trustlessly stake the Bitcoin. Okay? It provides a trustless yield earning opportunity. Okay? From the point of view of the chains on the right side, or any system, you have a very large, relatively stable asset that can provide security. Okay? So this is the matching, or perhaps the matching market, or the two-sided market that we want to create here. Okay. So one very important point here that I want to make is that this is a native, okay? A native staking primitive. What does that mean? That means that this is not requiring the Bitcoin to be bridged to these chains on the right-hand side. No bridging here. And so it's native, okay? So to build this native primitive is not easy. Not easy. Because Bitcoin has no smart contract. Native means that you want to build the staking contract on the Bitcoin chain itself, not on the proof of stake system. Okay, very important. On the proof of stake system, you can always write smart contract. For example, eigenlayer type smart contract to do slashing. We don't have that on Bitcoin, so we need to move a few things. And so the solution here involves combining multiple technologies to be able to do that. Okay? So I briefly mentioned here, one very important technology is this so-called extractable one-time signature. So it turns out that what we can do is to reduce all the slashable events on the proof of stake system in terms of a thing called equivocation. And extractable one-time signature is a special signature you sign that if you sign two blocks with equivocation, then the private key gets extracted from any observer, and that observer can now go and use that private key to slash the Bitcoin by spending. So Bitcoin chain, the contract is very dumb. All you can do is to spend a Bitcoin, and this private key extraction allows us to do this event. We also used Vitalik's idea of fanatic gadget, but we built a special fanatic gadget so that we can use extractable one-time signature. And very importantly, we also use a technology called Bitcoin timestamping, which enables us to have this concept of remote staking, where the staking is happening on the Bitcoin chain, whereas the security is happening on the proof of stake system. Okay? So combine these three ideas. We build a system to secure proof of stake chains. And one of the first chains that we secured is we integrated with other Cosmos chains. So we have now a partnership with many Cosmos chains to build this fanatic gadget on top of the system, on top of the Cosmos proof of stake system. Okay, so that's where our project was. So we start thinking, hey, you know what? In addition to chains, in addition to proof of stake chains, okay, there are also many, many new systems that are built not as chains, but as roll-ups. Okay, today is the roll-up day. So So how do we apply this technology from securing proof-of-stake chains, like Cosmos chains, to securing roll-ups? Okay, all right. So to understand that, we need to break down a little bit more about what are the nature of the security of roll-ups, okay? You can think of three, okay? One is that you want the roll-up, the blocks, to have execution validity, okay? That means you can't create money from thin air, okay? This is secure typically by two approaches, ZK and optimistic, okay? So Yao-Chi already talked quite a bit about that, so I won't mention it. Second is slow finality. That means you're waiting for the parent chain. So in the case of Ethereum rollup, it will be Ethereum. In the case of Bitcoin rollup, it will be Bitcoin chain. You wait for that chain to get finality, okay? Slow finality. However, by definition, slow finality means slow, and people are impatient, just by nature, people impatient. They want fast finality. Fast finality means what, right? Means that the sequencer creates a block, okay? Even before it gets onto the main chain, even before it gets confirmed on the parent chain, you would like to accept, a client would like to accept the transaction that block as final. Well, how can it be final, man? It hasn't even got to the main chain yet. Really impatient people here, okay? So the only way you can accept finality is to trust the sequencer. Hey, wait a minute, the sequencer is like one central guy. We're back to one central guy deciding. So it turns out that Bitcoin staking fits very naturally in this scheme, is that you already have the two provided by other technology, but Bitcoin staking can provide fast finality. So in other words, you can slash the sequencer. You can slash the sequencer if the sequencer tries to create two blocks. Okay, let's see how it works. All right. So on the right-hand side, we have the setup here. The sequencer deposits some Bitcoin staked on the Bitcoin chain using a Bitcoin staking solution. And then it sends blocks, L2 blocks, to the main chain, okay? Now, in an honest sequencer, it would only create one block at every height, okay? One block at every height, present to the whole world. And then at the end, you can now obtain your collateral back, your Bitcoin collateral back, as well as reward, okay? This is a happy path. In the unhappy path, the sequencer is now trying to attack the rollup user. How does it attack? Well, the sequencer creates two blocks, okay? One block, it presents to the user saying that, okay, you got a certain amount of money, okay? In the other block, where that money was not received by the user, is actually posted onto the L1, okay? So now, if the user accepts this block immediately and confirm, then it got cheated. This is an attack, okay? Now, the way to prevent this attack or to deter the sequencer from creating the attack is to use the Bitcoin staking technology and say that, okay, to create these two blocks, you have to use the extractable one-time signature to sign on both these blocks in order for that block to be Bitcoin finalized, okay? Now, so what is the good thing about that is that if this happens and the sequencer double signs on these blocks, then the extractable one-time signature says that the secret will be extracted and the Bitcoin will be slashed, okay? So this prevents a double spend attack against the user at a fast finality. Now, if the user is very patient and wait for B2 to be finalized before accepting the block, then there's no problem because it won't be cheated. But the whole point here is to solve the fast finality problem. Okay, good. All right. So going a little bit broader, we have quite a few projects building on Babylon right now. So on the left-hand side, you can think of is the supply side of Babylon. So Babylon is like a two-sided market. On the one side, Bitcoiners are supplying Bitcoin. So we have quite a lot of LSTs on top of Babylon. So you remember the first picture, right? The first thing that was built on top of the ETH staking primitive was LST. And the history is repeating itself. The first thing that builds on Babylon's Bitcoin staking primitive are Bitcoin LSTs, okay? And many wallets are integrating. On the demand side, which is to get the staking, we have, as I mentioned, Cosmos chains. We have a partnership with the Cosmos Hub right now to integrate Bitcoin staking with the Cosmos Hub. In addition, we have rollups, Bitcoin L2, there are now many new Bitcoin L2, and we are partnering with them to implement Bitcoin staking. We are also collaborating with rollup as a service, for example, Outlayer, etc. Okay, all right. We launched a testnet a few months ago, and we have obtained quite a lot of demand in 48 hours, 100,000 stakes. All right, a lot of people ask me, when is mainnet coming? When? Coming. So you see the problem is, okay, here's the problem, right? If you are a single project, okay, if you're a single project, you're just building by yourself, then when you launch, okay? You don't have to ask anybody. However, when you have so many ecosystem projects now, you have to go and talk to people, right? You can't just do it yourself. So that's the one issue. All right. Okay, so that's it for my talk. If you're interested, please connect with us on these meetups. Thank you.